All right, let's get right into it. Today, we are tackling a huge topic, something that could fundamentally change our digital lives, the quantum threat. We're going to break down exactly how a totally new kind of computer is getting ready to shatter the very locks that protect, well, pretty much everything you do online.
So, let's frame this with the one question that changes everything. For decades, all of our online security has been built on a single assumption for mathematics, that factoring huge numbers is just incredibly difficult. But what happens if that core assumption is wrong? What if a new tool comes along that makes it easy? That's the problem, right there.
Before we talk about how to break the lock, we really need to appreciate just how strong it's been. So first, let's take a look at the digital fortress we've all been relying on for years, good old RSA encryption. You know that little padlock icon in your web browser? Well, what's really going on behind it is a beautiful, simple math trick. See, a computer can take two massive prime numbers and multiply them together in a flash. But going the other way, taking that gigantic result and trying to figure out the two original primes you started with, for a normal computer, that's a practically impossible task. And that difficulty is the entire basis for the lock. And when I say difficult, the scale is just mind-boggling. I mean, look at this. If you gave a standard 2048-bit RSA key to one of today's fastest supercomputers, it would still take literally billions of years to crack. A quantum computer, on the other hand, could do it in a matter of hours. Think about that. That's the difference between never gonna happen and while you're out to lunch. So what is this new kind of key that can pick a lock that strong? Well, let's meet the game changer. It's a completely different kind of computer that just doesn't play by the old rules, and it comes armed with a very specific weapon. Okay, so here's the fundamental difference in how they think. Your laptop, your phone, they all use bits. A bit is like a light switch. It's either on or it's off. A 1 or a 0. Simple. But a quantum computer uses something called a qubit. Now, a qubit is more like a spinning coin. While it's in the air, it's not heads and it's not tails. It's kind of both at the same time. That's what we call superposition. And because of this, a quantum computer can explore a massive number of possibilities all at once, instead of checking them one by one.
And this is where the perfect tool meets its perfect problem. Shor's algorithm is a quantum program. It's not designed to check your email or play video games. It was built for one job and one job only, to take a huge number and efficiently find its prime factors. It is, for all intents and purposes, the perfect key for the RSA lock.
This quote really nails it. Shor's algorithm takes a problem that was considered intractable, meaning impossible to solve in any reasonable amount of time, and makes it tractable or solvable. That single shift completely demolishes the foundational assumption that our global digital security has been built on for decades. So, what happens when someone finally builds a key big enough to turn that lock? What does that world look like? Well, the dominoes start to fall, and they fall fast. The fallout here is just massive. We're not talking about one small system. We're talking about the very bedrock of digital trust. The encryption that protects your bank transfers, your private messages, the digital signatures that prove who you are, basically all secure web browsing. It all relies on systems like RSA and Diffie Hellman. And with a powerful quantum computer, all of it becomes an open book. Right. This is the big, flashing red question on everyone's mind. With a threat of this magnitude, you have to ask, is the sky already falling? Are we in trouble right now? And the answer, thankfully, is a little complicated. Okay, so here's the good news. No, we are not vulnerable today. The kind of large-scale, stable quantum computer you'd need to actually run Shor's algorithm against modern encryption, it hasn't been built. Yet. The key word is yet, because governments and massive tech companies are in a flat-out race to build one, and preparing our defenses for that day is a long, slow process that has to start now. And that brings us to what is maybe the most sneaky, immediate threat. It's not about what can be broken today, it's about what is being stolen today to be broken tomorrow. It's a strategy known as harvest now, decrypt later. Here's exactly how this heist works. Right now, as we speak, adversaries are sucking up huge amounts of encrypted data off the internet, government communications, corporate secrets, maybe your private health records, and they're just storing it on massive servers. They can't read it, yet, but they're playing the long game. They're waiting, because in, say, 5 or 10 years, when they finally have that quantum computer, they can just pull all that old data out and decrypt it. For any secret that needs to stay secret for more than a decade, the clock is already ticking. So, does this mean everything is just broken and we should all give up? No, not quite.
What this threat has really done is kick off a brand new global arms race in the world of cryptography. It's an epic battle between the code breakers and the code makers. And it's important to realize that this threat is actually very surgical. It's not a nuclear bomb that wipes out all encryption. It specifically targets what we call asymmetric or public key cryptography, things like RSA that are used to establish a secure connection in the first place. Other kinds of encryption, like the symmetric systems used for the actual data transfer, are far less affected. So the whole house isn't on fire, but the front door has definitely been kicked in.
The path forward from here is actually pretty clear, and it comes down to 3 big steps. First, we all have to just acknowledge that our current systems are on borrowed time. Second, we need to understand the timeline. This isn't a problem for tomorrow, it's a problem for today that will have consequences in the future. And third, we have to start the massive global migration to new kinds of encryption that are quantum resistant. And that effort is already well underway.
And that really leaves us with one final fascinating thought. We spent all this time understanding how the old locks get picked. So the next logical question is, what do the new locks look like? How in the world do you build a digital fortress that a quantum key can never, ever open? We are going to dive deep into that incredible topic, the world of post-quantum cryptography, in our next explainer.